Hey guys, it's Miss Rainey. Today we're going to learn about ionic compounds. First thing we're going to do is look at how to draw Lewis dot structures for ionic compounds. Are you ready to get started? Let's go. First of all, ionic bonding in general, what is it? Well, we already know that cations lose electrons. These are generally the metals. They'll lose electrons to become positive ions. You remember that the cations are positive because that little plus sign right there in the word. And then anions gain electrons. These are generally the nonmetals to become negative ions. And you remember that they're negative because it's a negative ion. Okay, so where do the lost electrons go? And where did the gained electrons come from? Well, the cations will lose electrons to the anions, and the anions will gain electrons from the cations. Once the electrons have been lost and gained, the ions have opposite charges, and opposites attract. It's a match made in heaven. So, look at your worksheet called Ionic Bonding, or at least the side of your worksheet called Ionic Bonding. Let me show you what I mean. So it says the formula is KCl. So for electron dot of atoms right here, we know that K is in group 1. Since K is in group 1, it has one valence electron, so its electron dot structure will look just like this, K with one dot. We also know that Cl is in group 17. Group 17 has 7 valence electrons, so it'll have 1, 2, 3, 4, 5, 6, 7. So Cl has 7 dots and K has 1 dot. You also hopefully know that chlorine's going to want to gain 1 electron to become like a noble gas, and potassium's going to want to lose 1 so that they both can have a filled outer energy level. So the electron from potassium is going to go to that empty hole for chlorine. So that the electron dot for the compound we'll have K plus and Cl minus. And since Cl is negative, we show that it's gained electrons by giving it 8 dots. And so the electron dot of compound is just that, a K plus and a Cl minus right next to each other. So let's try one that you're going to have to do from scratch. We got BaO. So first thing you're going to do is write Ba and O. This is in the electron dot of atoms column. So look up barium. Barium's in group 2, which means barium has 2 valence electrons. Give it 2 dots. 1, 2. And oxygen's in group 16, which means oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. So barium's going to want to lose 2. Oxygen's going to want to gain 2. So for the electron dot of the compound, we will have Ba with the plus 2 charge because it's lost 2 electrons, and O with the minus 2 charge because it's gained 2 electrons. And then we're going to give that O 8 dots to represent that it's gained 8 electrons. Let me see if I can make my pen thicker here. Alright, so let's look at another one. On your paper you have CSF. Oh, that should be much better. You try that one on your own. Pause the video, substitute, and try this one all by yourself. Okay, so hopefully you tried CSF by yourself, and I got a thicker pen. We have CS, which 1 valence electron because it's in group 1. And F with 7 valence electrons because it's in group 17. There we go. And so CS is going to lose 1 and F is going to gain 1. So our ionic dot of our compound, or electron dot of our compound, will have CS with a plus sign and F with a minus sign. And then F also gets all 8 electrons. Alright, we're going to do one more together. This one's K2O. So first of all, that little 2 there means that there's 2 potassiums, a K and another K. And I'm going to put the O in between them. It's KOK. Potassium gets 1 valence electron, potassium gets 1 valence electron, and oxygen gets 6. 3, 4, 5, 6. So it looks like potassium's going to lose 1, and the other potassium's going to lose 1, so that in the end you have K plus, O minus 2 because it gained 2 total, and then another K plus. Don't forget that oxygen gets 8 dots now. It had the 6 plus 2 more. And also make sure that you put them in order KOK instead of KKO, because the positive ions, the positive potassiums, do not want to sit right next to each other because the positive charges would repel, not attract. So you want the positives on either side of the negative so that the opposite charges can attract rather than the positive charges repel. Okay, you're on your own. Practice the rest of these. I'll give you just a few minutes and then we'll start the next topic. Good luck!